continuing along here, the following graph describes Marissa's drive to work. And so I'm going to need to do, well, I don't actually know. I haven't read. I think there's a bunch of questions down here, but I'm assuming I'm going to need to figure out, like, I'm going to have to describe all of these times here in probably some sort of paragraph or maybe point form. Just off the bat, I do notice that there are 3 times where there's been no rate of change, where there's no slope. We're not getting further or closer to wherever we are or wherever we're going. So distance, this is her distance, and this is time, and this is the distance, I guess, drive to work. So maybe this is our distance, maybe from home. So I would assume this is from home here. And so we're getting further and further and further away from home. And there are 3, like I said before, or was trying to say before I got distracted, there are 3 times where there is some sort of stopping. And so we're going to need to know, probably, we'll have to see the questions. We're going to have to know what those are and how long they take and whatever. So let's take a look here. How long did she stop for? Oh, during her trip. Okay, so how long did she stop? Well, she's at home at the beginning here, and then she drives to work, and then she stops. Okay, and so that's here. Now our scale looks to be, I think ones. If these go up by ones, maybe. 1, 2, 3, 4, 5. Yeah, okay, so they do go up by ones. I'm actually just going to, because this is not too bad, I'm actually just going to label all of these while I have the time. Well, whatever, I'll stop at 20 here. So from 5 to 7 here, there's some stopping. And these are, is it in minutes or seconds? Okay, it looks like it's in minutes. Okay, so, uh-oh. Let's make sure this actually works. So from 5 to 7, there was one, I'll do a little bullet point. There was a stop, so that's for 5 to 7. So that was a total stop for 2 minutes. I was going to write seconds, but no, it's 2 minutes. If I actually knew how to spell minutes, I'll just put MIN. And then we have, let's take a look, where's our next stopping spot? And we stop here to here. So that's all the way from 12, okay, to 20. So from 12 to 20, which would be 8 minutes. So we did another stopping there. So from 12 to 20, we stopped, which was 8 minutes. And did we stop again? Is there a stop at the end? There is. So we do go all the way up here. So 21, 22, 23, and 24. And so the last ones here are where we stopped for the last time here on our trip. So 23 to 25 was our last stop, which was a total of 2 minutes. So how much did we stop in total? 2 plus 8 plus 2. So therefore, 2 plus 8 plus 2 equals 12 minutes, which actually seems a little bit absurd to think that this is a 25-minute trip and 12 minutes of it is spent stopping. So that's like almost half the time, right? Okay, give one reason why she might have stopped. Oh, well, there's lots of reasons, I guess, why you could stop. So I mean, it doesn't really matter here. We're just kind of guessing. So you could have some traffic, or we could have one in my house that happens all the time is a train. So a train comes by and takes forever, especially if the train has to stop at some point. There's half your life gone. Traffic, train. I don't know. Maybe you're grabbing like a coffee or some sort of breakfast. I'm assuming that this person, when I think of going to work, I think in the morning, but I mean, it could be lunch or dinner or whatever, right? So it could be just food. And so there's a bunch of different reasons why she could have stopped. After 10 minutes, let's see, what distance is she from her house? So again, her house is at the beginning. At the beginning, she's 0 kilometers away from her home. And then at 10 minutes, we want to know how far away. So I'm going to draw a ruler up here, up to 10, and we'll see how far away we are. So I've drawn a line now, all the way up. We start at 10 minutes, and you drew a line. We did this before in the previous units where we drew the line up for the line of best fit, and we had to predict. Well, this is not a line of best fit. This is a time and distance graph, but we can do the same thing, go all the way over. And it looks like we hit, the scale is 1, so we look like we're at 11. So at 10 minutes, we are 11 kilometers from home. So 11 kilometers from her house, Oh, and what time is she 7 kilometers from her house? Okay, so now I'll draw a line, but I'll do this first. We're here at 7 kilometers, so we're going to want to go over until we hit it and then come down. So it looks like 8, but I'll draw a line anyways. There's my line. So again, I went all the way across, went down, so 8. So at what time is she 7 kilometers from her house? So I guess 8 minutes in is probably what we want to write. So 8 minutes into her drive. All right. Calculate the rate of change for each section and then describe it. Describe her drive to work. So I might include both of these together, but we need to do a bunch of different sections. So I'm going to do this in green. I'll calculate this here. I'm not going to do the stops because those are just stops. So here I'm going to say, what is my rise over my run? So this is my rise and run. So I go up 5 and over 5. Okay, so up 5 over 5. So it's going to be a rise up of 5 over 5, which is 1. So we got a rise of 1. This right here, section 2, is going to have a slope of 0. And then section 3, that's going to have a rise over our run. That's our slope or our steepness. We're going to rise up this much and go over here. So the rise would be from 5 to 15. So that's a rise of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And then a run of 1, 2, 3, 4, 5. 10 and a run of 5. 10 over 5 is 2. So we get a rise and run of 2. So that's a lot steeper than 1. Section 4 is going to be another stop. So it's going to have a slope of 0. That's what we did here. This was a stop. So we have 1, 2, 3, 4. Okay, so now I've got another slope here in section 5. So we have a rise over a run, and we go up 1, 2, 3 over 1, 2, 3. So it's 3 and 3. 3 over 3, which is 1. And then section 6 here has a slope of 0 because it's a stop. So just taking a look here, I have a slope of 1, and then I have a stop, then I have a slope of 2, which is a lot faster, then I have a stop, then I have a slope of 1 again. So in the middle of my drive is when I would be driving the fastest, or Marissa here would be driving the fastest, and then I have 3 stops. So I guess I would just have to now translate that over to my my drawing here. So I'll do that, and I'll get back in a moment. All right, so rate of change in each section of the graph, and so we'd already calculated this. I just kind of wrote this down here, so you can always pause it if you need to and just copy it. But we have here 0 to 5, so in the first 5 minutes we have a slope of 1, and then we stop for 2 minutes, and then we have another slope from 7 to 12 of 2, which is definitely the fastest. We stop again here. We have a slope of 0. And then we stopped, I think that was for 8-minute stop. And then we drive again here, and we drive again for 2 minutes, or sorry, 3 minutes, and again at a slope of 1. And then the last area here, we stop again for 2 minutes. And so that was the rate of change we calculated. But then in part F, we need to actually kind of write down maybe what happened. So describe her drive to work. So we need to describe, and we're going to use the rate of change to help us describe that. And you can see I've already done something. Off to the side, I wrote this, rate of change or your slope, kind of however you want to look at that, or your steepness. Now I've told you before, and we've done a lot of this now, it's rise over run. And if you look on the y-axis, this is our y, this is our rise, and this is our x, this is our run. It said right there kilometers, and here it said minutes. So that's how I got my rise was in kilometers, and then my run, but that was supposed to be in a different color. Run is in minutes. So our slope is going to be kilometers per minute. So we have 1 kilometer per minute or 2 kilometers per minute. It means we drive, it takes in 1 minute, we drive 1 kilometer. And before and then in the fastest area, we had in 1 minute, we drove 2 kilometers. Those were our 2 slopes, or 2 rates of change, or our 2 steepnesses. Okay, so when I look at that, from 0 to 5, in the first 5 minutes, Marissa drove to work. And there was a rate of change of 1 kilometer per minute. So that's what, in 5 minutes, she was driving, and she was driving at a speed of, I guess, 1 kilometer per minute. And then from 5 to 12, she stopped, maybe a traffic jam. There's a 2-minute stop. From 7 to 12, we continued driving faster. We drove at a rate of change of 2 kilometers per minute. Then we had a big, from 12 to 20, we had a big 8-minute stop. Maybe there was some food or coffee or something that we had at this time, or Marissa had. Then she continued to drive at a slower rate again, back to the original rate of 1 kilometer per minute. And then did it for 3 minutes. And then for the last 2 minutes, there was some sort of stop. Maybe that's when she took a phone call. So I'm going to zoom this out here for you to copy this down. But this is what I'm hoping for when you do these sort of things. When you have to describe some sort of event like this, that you're going to use the rate of change. And so you can see that I've used the rate of change in there. And then I've just kind of made up some things to describe what could have possibly happened.